Our next speaker is Professor Dan Lee. He is an ARC Future Fellow and co-director of the Monash Centre for Atomically Thin Materials. His research is centred on graphene-based materials. Since 2006, his group has been developing innovative concepts to address the key scientific and technical challenges relating to scalable synthesis, processing and assembly of graphene-related materials. His research goal is to develop new materials to address the great challenges that our society faces in energy, water, healthcare and environmental protection.
Yeah, thank you very much, Claire. And first of all, I'd like to thank you all for coming today, and also like to thank our Associate Dean Research, Anna, for supporting this event, and also like to thank Claire, Tickenham, and Ashley for organizing everything. Thank you so much for support. And as Mike just mentioned, I'm a co-director of the center, and my role is mainly to help to coordinate research related to application and engineering side of graphene, particularly for graphite-derived graphene. So you might wonder why we like this kind of black stuff, and one of the key reasons is because you look at this graph. There are many ways you can make graphene. To make graphene from graphite is one of the most scalable and most cost-effective way to make graphene in large quantity. And it can be used for a range of large volume applications. And so because from engineering point of view, we really want to focus on something that can directly benefit our society and our industry. And the second reason, as you have heard, Australia does have graphite mine. Actually, in the past years, there are quite a few companies established to explore graphite, both in Australia and overseas. And there is strong demand for developing new techniques to add value to graphite. And we think to add value to graphene, one of the most efficient ways is to make graphene and graphene-based products. So that is one of our mission, to help the industry to grow in this new business. So we have to talk about Mike have talked about the exciting science about the graphene, but for my part, I really want to to tell you what our engineers can do about the graphene, how we can help you. And the key point I want to mention is that, and actually it takes quite a few engineering steps to bring graphite into real graphene-based products. And you might have heard a lot of techniques reported in the news that you can make graphene from graphite in large quantity and really low cost. Indeed, there's quite a few companies that are already established in the world to commercialize this production. But I want to say here is that production of graphene is just the first step of graphene computation. Most importantly, you have to find ways to functionize the graphene. For example, for some applications, you do have to functionize the surface chemistry of the graphene, make it suitable for different applications. You also have to find ways to engineer graphene into desired architectures to make sure the graphene can deliver the properties you want. And also, you have to find engineering ways to engineer the interactions of graphene materials with other components, other materials to build up real products. So and also for each step, first you have to develop the concepts in the lab, and then you have to scale up. In terms of scale up, that could be very different from the techniques in the lab. There's a lot of IP could be produced during this upscaling approach. And also you have to find ways to control to monitor the quality of the materials. And despite the 10 years of development, I have to say there's still plenty of opportunities to complete the value chain to make it graphene really valuable, and you can make profit from this new materials. So to give more some ideas, specific ideas, what we engineer do with the materials. Just give some examples of our own materials. And I start as Claire just mentioned, I started working on graphene 10 years ago. The first thing I did is to develop techniques to make graphene soluble in water. and to make sure it can be processed in using cost-effective techniques. And the second thing I did is to develop techniques to process graphene dispersion into this kind of architecture, graphene-based bulk materials. Two types of materials we have developed. One is called graphene hydrogel membranes, and the second one is the kind of foam-like structure. Actually, these two materials have very different properties. And for the first one, it has a combination of traditional porous carbon and hydrogels. Actually, it can generate very, very different properties that other materials cannot do. And for this one, actually, we have made the world's the most lightweight, the elastic materials in the world from just simply use graphene. And in the past few years, we have been working with experts in some application areas to develop applications for these materials. And particularly, we have made the most compact supercapacitors so far in the world. And also, we're developing other applications as well. I don't have time to detail all the technologies we have developed, but I do want to emphasize one point is that to engineering graphene actually is very, very challenging. It's a very difficult task. And one point I want to emphasize, to every success of the graphene-based products, our understanding is that it involves the integration of multiple disciplines. Just give you specific examples. That's also the key point I want to make today from my talk, is that what's the key strengths of Monash graphene research. I think George talked about the facilities and also about the people. I think that's the key. I think is the people. We do have established a strong culture for collaboration. And so here, just to give you an example. As I just mentioned, we have kind of invented a new type of graphene-based hydrogen materials, but we do have to. But the structure is very complicated. We do have been collaborating with these scientists in these facilities. George has just mentioned, to understand the structure of the materials, and also to collaborate with the simulation and computation experts, to understand the structure and properties of the materials. We have to talk with the chemical engineers to find ways to scale up this process for large production. We have been also working with membrane separation experts and polymer experts like George Simon, and to develop a new generation of membranes for separations, for water purification, and for chemical separations as well. And for the supercluster applications, and we have been collaborating with chemists like McDock, and we have been trying to further improve the performance of the energy storage devices. So more than, as you can see, from this list, this is some people we list in the at least that's work on graphite-derived graphene, and I think Monash and Rico will talk about later how they engage with industry. And for these experts, actually they don't directly work on graphene. They collaborate with with graphene researchers, and they mainly focus on developing new applications to solve the problems for their own fields. So I'm really proud of being part of this team, and because we have been collaborating a lot, with all these people, and hopefully you will talk to some of them and understand our capabilities and the opportunities available for collaboration. And to conclude, I hope today's event will convince you that we have established very strong capabilities for graphene research, and we have the strong passion to work with you in the future to create new business in Australia. Thank you very much, and I look forward to talk to you and work with you in the future. Sorry.